This is video number 4 from sections 2.1 and 2.2, more on equations of linear models. We're just going to work one more example. This time we'll do one that has more than just the 2 data points. This particular data comes from the National Center for Health Statistics, and it's talking about births that take place outside of marriage in the U.S. for the last several years. So you can see there you've got various years, and then for each year you've got the percentage of all births that are taking place outside of marriage. And you can see just from a quick glance, it looks like there's an upward trend to those numbers. As usual, we need to define a couple of variables. In this case, P is going to represent the percentage of births that take place outside marriage, and T will stand for the number of years since 1980. First, we're being asked to identify the independent variable and the dependent variable, and as usual, the first variable that they mention is our dependent variable, our y variable, so P is like our y, and the second variable mentioned, in this case T, functions as our x, as our independent variable. This is because if you said, hey, what percentage of births are taking place outside marriage, the answer is, well, it depends on what particular year you're talking about. Let's go down to letter B. Again, this has been normal for us to have to adjust the data to fit our variable definitions. I don't want to write 1,985 in that box, and I'm not going to. T doesn't stand for the year. T stands for how many years it's been since 1980. So that means 1985 would be 5, and then I would have 10, and so on, counting by 5s down that column. And then I go to P. Well, P says it stands for the percentage of births outside marriage. That's exactly what they gave me, the percentage of births outside marriage. So I can just copy those numbers right into the chart. All right, I've got those numbers copied in. That takes us to letter C, which asks us to go to the calculator and draw a scattergram of this data. We'll go ahead and follow the instructions that are given here to do that. All right, so turn your calculator on, and then we'll follow those steps. This is a slightly faster way to get the scattergram up than what we did before. This is what you should do from now on. Step 1, remember, is to hit Stat, and then choose Edit, either by clicking the number 1 or simply by choosing Enter. If you have old data sitting in here, you need to get rid of that by arrowing up to the name of the list, hitting Clear, followed by Enter. So that wipes out L2, then I'll go over to L1, go up to the name of the list, Clear, and Enter. And now I'm ready to type in that data that we had in the chart. Go ahead and do that. So there's my T data, 5, 10, 15, 20, 25, 30. You can either use the down arrow to go from line to line or just hit Enter between each line. Then I will arrow over to L2 and enter in those numbers. All right, and so I've got all my data for the percentages now in the L2 list. Once your data is in, the fastest way to turn on the plot is just to go over to the Y equals button and take a look at this part up here that says plot 1. If it is highlighted, that means your plot is on, which is what we want. Now this is very important because at the end of this problem, you may want to come in here and turn that plot off, because if it's on, it'll mess up other types of graphing. To turn it off or on, you arrow up to it and then hit Enter. If it stops being highlighted, then it's off. Of course, I want it to be on right now. I'm going to hit Enter again, and now it is on. The last thing I need to do is go to that special window for scattergrams. It's Zoom 9. So hit Zoom and then choice 9, and now we can see our data. The handout, part D on the handout says that Our goal here is really just to find the equation of a line, if we think that's appropriate. We don't really have any need to make adjustments to our window to copy this picture down. If I decide there's a linear pattern, I really just need to use this picture to identify two good points to use. Now, question D asks, is there a linear pattern to this data? And I would say yes, absolutely. It's not perfectly aligned, but certainly there's some sort of upward line that does a decent job at describing this data. Well, letter E on the handout goes on to say, let's pick out 2 points that if we connect those 2 points, we think that will give us a pretty good model. As usual, there are good choices and bad choices. A bad choice, for example, looks to me to be this 3rd and 4th point. I'm imagining connecting a line through those points, and I think it would just be a little bit too flat to capture the overall pattern. I think there are a lot of good choices to pick. How about the 1st and the 5th? I'm feeling like if I connected the 1st and 5th points, you might even try on your own calculator setting a ruler physically on it and helping you in that way to determine which 2 points to pick. There are other good choices, but let's go ahead and choose the 1st and the 5th point. So back to the handout, we said we wanted to choose the 1st point and the 5th point to create our linear model. All right, so that gives me the 2 points 5, 22 and 25, 36.8. Just like in the last problem, now that I have my 2 data points, I can go ahead and crank out the algebra in order to find the equation of the model. That means I'll have to begin by thinking about the slope. So y2 minus y1 over x2 minus x1. Work out the calculations. Looks like we're going to have 14.8 divided by 20, and we'll reach for the calculator. I got 0.74. The directions say round these values to 2 decimal places. I don't even have to round. It came out exactly 2 decimal places. Once again, I now have a choice. I could use the y equals mx plus b method, or I could use the point slope formula. Why don't I go ahead and use y equals mx plus b this time, just for the practice. If you really prefer the point slope formula, then you go ahead and do that. All right, the y equals mx plus b method says that I need to begin by filling in the slope. We just figured out that the slope is 0.74. So I know my final answer is going to look like this, y equals 0.74x plus b. Then I temporarily fill in one of my 2 points. It doesn't really matter which one. Maybe I'll just go ahead and pick this one. The numbers look smaller. I temporarily fill in those values for my x and y. So that would be 22 where the y goes, and 5 where the x goes. And then I just need to do some of the math. 0.74 times 5 is 3.7. And then lastly, subtract 3.7 from both sides. And one more time going to the calculator. And I get a final b value of 18.3. So now we can write our equation down. Looks like our final equation, putting it all together, is going to be y equals 0.74x plus 18.3. I'm remembering, though, that I need to use the correct variables, right? We can carry out our work with x and y, but our variables in this problem are p and t, which means my final equation should say p equals 0.74t plus 18.3.